As we continue on with section 5 of chapter 11, we're going to continue looking at volumes like we did in section 4. And as you can see from the title at the top, we're going to look at pyramids and cones today. So first, let's get the equation for the volume of a pyramid. The volume of a pyramid is equal to 1/3 times the area of the base times the height. So that's the volume of a pyramid. Okay? The volume of a cone is equal to 1/3 times pi times radius squared times height. Okay, so basically the two equations that we're working with today are identical to the ones that we learned yesterday. The only difference is these are multiplied by 1/3, and that has to do with the slant of the pyramid and the slant of the cone. So on the next couple slides, we're going to do some quick examples, and then from there we will be ready for class tomorrow. So first, we're going to look at an example of finding the volume of a square pyramid. And if you think back to section 3, when we were talking about the lateral area and surface area, we used what was known as the slant height, which went from the vertex to the side. Now this equation that we're using with the volume equaling 1/3 times the area of the base times the height, we'll actually use the height, which goes from the vertex to the center of the pyramidal base. Okay, so it's not the slant height we're using in this equation, it will be the actual height, which is the altitude. So for this particular equation, all you would do is you plug in the numbers. The volume is equal to 1/3 times the area of the base, and in this case it's a square, so it's length times width, and we have a length of 7 and a width of 11. So 1/3 times 11 times 11, and the height in this one also happens to be 11. So at this point you would pull out your handy dandy calculator. I would always leave the 1/3 to the very end. So we have 1/3 times 11 times 11 is 121. So 1/3 times 121 times 11. Continuing on with that, we have 1/3 times 121 times 11 is 1,331. So the volume of this pyramid would be 1,331 over 3, which in this case does not come out accurately or evenly, so it would be approximately 443.7. And remember, with this being a volume, the units will need to be centimeters cubed. The last example we're going to do in this video is going to be for the volume of a cone, and this is number 12 in your book. It can be found on page 634, and basically we're using the equation that we had written down from the first part of this video, which is volume is equal 1/3 pi times radius squared times height. And keep in mind, the height doesn't always have to be inside the cone. It can be outside, like the altitude is here. And the cone doesn't always have to be perfectly up and down. It can be what is known as a slanted cone or an oblique cone. And so from here, all we need to do is plug in the numbers. Volume is equal to 1/3 times pi. The radius in this would be 2, because it tells us that the diameter is 4, so half of that is 2. And so it's 2 squared and then the height is 5.5. And as I said before, I would leave the 1/3 out until the very end, so it's 1/3 pi. 2 squared is 4. If we multiply 4 times 5.5, we get 22. So the volume would be equal to, if it had said even terms of pi, it would be 22 pi over 3. As we see up here, the directions say to the nearest cubic inch. So we multiply that out, and 22 pi over 3 would end up giving us a amount of 23 inches cubed. So just like yesterday, this section is all about plugging numbers in to an equation. It's two simple equations. We're taking the equations that we use for the volume of a prism and the volume of a cone, and we're multiplying that by 1/3, or you could say we're dividing those equations by 3. So if you have any questions, come to class with them so we're ready to go. Otherwise, we'll go through a couple examples after we grade our homework, and you'll have some time to do your homework.